Hello once again. This is Teacher King David. We are still on functions. So we're going to see how we can find domain of function when you are not given conditions. So how can we find domain of any function when you are not given conditions? For example, let us start with, let's say that our f of x, let's say start with the rule 1. Let's say that f of x equal to p of x divided by q of x. So where p of x and q of x are polynomial. Where p of x and q of x are polynomial. So for the function which has numerator and denominator, but those numerator and denominator are polynomials, the domain of definition, we say that x is a member of real number such that q of x must be different from 0. Q of x must be different from 0. So that's how we can do it. For example, let us see examples. Find a domain and range of the following functions. Find the domain and range of the following functions. So we have, this is number 1. That is number 1. We have A. Number 1A, it is saying f of x equal to 1 over x. B, let's first do A. So find domain and range of the following functions. We're going to find domain of this function. So this is our function. It is in the form of fraction where we have numerator and denominator. So domain here, dom f, we have to say that x is a member of real number such that x must be different from 0. That's the condition. So if x is different from 0, we can get a set of real number. So now what is if x is different from 0, when we say a real number, a real number we mean from negative infinity to positive infinity. That's what it means, a real number. So, but we have a number which is not inclusive or which is not included. That number is 0. So, meaning that our dom f is going to be from negative infinity to 0 excluded, union from 0 to positive infinity. Let me repeat here. We have our domain it must be a real number, but we have only one value which is not included. And that value which is not included is x equal to 0. So mean that in the set from negative infinity to positive infinity, there is a number which is 0 that is not included. So we have to give this 0 a transfer from this set. If we give it a transfer from this set, so what does it mean? It means that this value is going to be excluded. So that's why I'm saying from negative infinity to 0, union from 0 to positive infinity. Or we say dom f is a real number except 0. You can also write it like that one. So that was A. B, we have f of x equal to x plus 3 divided by x squared minus 4. So how can we find domain? Let's first find range here before we go to that number B. Let's first range of A. So how are we going to find range of A? Because we have to find range. So to get range, we let f of x to be equal to y. So our y will be equal to 1 over x. So then yx equal to 1. So where x is 1 over y, then we interchange, so you get that inverse of f of x is 1 over y. 1 over x, sorry, because we interchange. You see the inverse, f of x is the same as its inverse. Is the same as its inverse. If they're the same, so you see the format are the same. So meaning that the domain of inverse of x is also a real number except 0. So we are done with number 1a. They were asking range and domain. So let's go here to f of x. So our f of x here, we have x plus 3 over x squared minus 4. How can we find domain? Dom f, we have to say, dom f, x is a member of real number such that x squared minus 4 should be different from 0. This is a condition. Then after that condition, what are we going to do to get a real domain? So we let x squared minus 4 to be equal to 0 in order to get the values of x. So here, this is x squared equal to 4, where x is plus or minus 2. So what does it mean? It means that our x is different from negative 2, or x is different from 2. So when you see a real number, we mean from negative infinity to positive infinity, except negative 2 and 2. Except negative 2 and 2. So meaning that what I'm saying, domain, it will be like a real number except negative 2 and 2. A real number except negative 2 and 2, which is dom f, which is from negative infinity to negative 2 excluded, union, from negative 2 to 2 excluded, union, from 2 to positive infinity excluded. Always positive and negative infinity are excluded. So that's for where we have f of x, which is in the form of fraction. So normally 2. What about if you have a polynomial like f of x equal to p of x, where p of x is a polynomial? What if f of x equal to p of x, where p of x is what? A polynomial. Domain there, dom f is a real number. That's domain, meaning that our dom f is from negative infinity, positive infinity. So meaning that there is no condition. There is no condition. Examples, let us set examples. Examples, it is saying find domain of definition of the following functions. So we have A, this is like number 2, example number 2. Our A is saying f of x equal to 3x minus 1. This is a polynomial. This is the first degree polynomial, which is a linear function. So now, it is a polynomial. Since it is a polynomial, our dom f is a real number. Nothing else. So B we have like f of x equal to x squared plus 2. So now, what will be the domain here? Yes, the domain will be a real number because this is a second degree polynomial. So here our domain also, because there is no condition, our domain is real number. So let us see C. Our C also, it is f of x equal to x power 3 plus 2x squared plus 1. So this is also polynomial, a third degree polynomial. So our dom f also is real number. I think up now you don't have any question. So let's go to see how we can find other types of the domain. So now let us see when you have f of x equal to nth root of p of x. So this n can be even number, or it can be odd number. It can be odd number. Let's start with odd number. For n equal to odd number, for n is odd number, where p of x is a polynomial, So well, then let's start for n equal to odd number. For n equal to odd number, dom f is a real number. Domain is a real number because there is no condition. Domain is what? A real number because we have no condition. But for n is even number, domain, we say that dom f, we say that x is a member of real number such that p of x is greater or equal to 0. That's the condition. But when n is odd number, we don't have a condition. We say that domain is real number. Examples. Let's say we have, the question is saying find domain of definition of the following function. Functions. So we have f of x equal to square root of x plus 2. Find domain of that. Then how can we find domain of that? So we say dom f, because the value we have here is 2, so meaning that is even number. Since the number that is there is even number, we say that domain x is a member of real number such that x plus 2 is greater or equal to 0. So meaning that we're going to let x plus 2 to be equal to 0 in order to get the values of x. So our value of x there is negative 2. So from there we can start the sign. We start the sign. So we have x from negative infinity to positive infinity. We have negative 2 here. We have our equation which is x plus 2. So this negative 2, if you bring negative 2 here, you're going to get 0. So this side, because it is positive there, it will be negative, and here it will be positive. Or between negative infinity and negative 2, there is like negative 3. If you bring negative 3 here, it will be negative 3 plus 2, that's negative 1. That's why we have a negative. But from negative 2 to positive infinity, there is 0, there is 1, there is 5. If you use 5 plus 2, that's 7, and that 7 is positive. So that's why I have positive. And it is greater. Greater means where we have positive. So our x will be a member from negative 2 included, because we have greater or equal to positive infinity. So this is our domain. So therefore, our domain, dom f, we say that x is a member from negative 2 to positive infinity. Excluded. Always infinity are excluded. They are excluded, not included. So let us see B. B is saying f of x equal to cube root of x plus 2. You see it is the same function but different of nth root. Here it is cube root. Because it is cube root, you know that a cube root of -8, for example, a cube root of -8, it is -2. Because that is like cube root of -2 power 3. You know, 8 is 2 power 3. -2 power 3 is -8. So this cancels with that, remain with only -2. So that's why when n is odd number, to get the nth root of that polynomial, it is possible. Or to get the nth root of that number is what? Is possible. So here domain f is what? Real number. Simple as that one. Because there is no condition here. Okay, let's go to C. I hope you are getting it very well. So let's go to C. C, we have f of x equal to square root of x squared minus 9. So here the condition, we are going to say dom f, x is a member of real number such that x squared minus 9 must be greater or equal to 0. So we're going to follow this condition. X is a member of real number such that x squared minus 9 is greater than or equal to 0. So we let x squared minus 9 to be equal to 0 in order to get values of x. So our x is plus or minus 3. So from there, x is plus or minus 3. Then what is the next? We're going to start the sign. Let us start the sign in order to get where the values of x can satisfy this condition. So we have x from -infinity to +infinity. Between -infinity and +infinity, we have -3 and we have +3. So our equation is x squared minus 9. So here it will be 0, 0. So now, between -infinity and -3, we have like a -4. If we bring -4 there, that is -4 squared, that is 16. 16 minus 9, that is 7, which is positive. So between -3 and 3, there is 0. Let us use 0. 0 squared is 0. 0 minus 9, that's a negative. Then between 3 and +infinity, we have like 4. That's 16 minus 9, which is 7. And that value is positive. So we have greater or equal. Greater means we have a positive sign. So our x will be a member from -infinity to -3, included union from 3 included to +infinity. So that's the domain. Our dom f, it says that x is a member from -infinity to -3 included union from 3 to +infinity. So that is our domain of definition. I hope you don't have any question from there. Okay, so what if we find that now the condition is like f of x, if you find that our function is like p of x divided by square root of q of x. P of x divided by square root of q of x. How can you get the domain? So here you see where p and q, where p of x and q of x are polynomials. So how can you find domain of that one? So here domain, we say that dom f is x is a member of real number such that because when we have, let's use n here, nth root. Let's use nth root. So let's ask for n is where n is even number. For n is even number. So when n is even number, we say that domain x is a member of real number such that q of x is greater or equal to 0. Sorry, it is only greater because if it becomes 0, n number divided by 0 is infinity. So Q of x is greater or, Q of x is greater than 0. Q of x will be greater than 0. So when you have f of x equal to p of x divided by the nth root of q of x, the domain is, for n is even number, we say that x is a member of real number such that q of x must be greater than 0. Then now, for n is odd number. For n is odd number, we say that x is a member of real number such that q of x is different from 0. X is a member of real number such that q of x is different from 0. So meaning that dom f, our dom f, it will be x which is a member of real number such that q of x is different from 0. That will be our condition. So we are going to see examples about equation 4.